This is Mosham Chaudhary, and today I am going to discuss regarding computer-oriented numerical methods. This is my first video, so to be honest, I'm a little nervous. I might make some mistakes, so pardon me for that. You can point out the mistakes in the comment section below, and I'll try to improve myself. Let's start. So today we are going to start with the introduction. What is computer-oriented numerical methods and why you should be studying this numerical method. So why do you need conm? Suppose I give you a simple problem. I ask you that x plus y is equals to 10 and 2x minus y is equals to 20. Then what is x and y? If I ask you to solve this, what will you do? You will take this as equation number 1, this is equation number 2, you will add 1 and 2. If you add 1 and 2, x will cut out, so I have thrice x, which is equals to 30, and hence I have x is equals to 10. So once I have x is equals to 10, I can either put it in this equation or I can put it in this equation to find out x and y. So this is easy. This can be done manually also with the help of pen and paper. Now let me give you another example, and right now let me ask you that if what is x to the power 51 plus y to the power 31 is equals to 10, and x to the power 3 plus y to the power suppose 8 is equals to 20. And these are some made up equations, and just for reference purpose I'm giving them. I ask you to solve this. How will you do so? How will you? Well, this can be solved, but in order to solve such kind of methods with the help of pen and paper, it requires a lot of time, effort and computation, and it is also not justified because it's a very simple equations. To be honest, these are not even real life equations. If the practical real life problems that we are surrounded with, those are nonlinear equations, and those nonlinear equations are of very higher orders and very complex equations. So how can we solve them? For such kind of problems we require the help of computers. Why? Because computers are very good at doing the same thing many times. Suppose I can perform one single operations 1000 times in a computer within 1 second, but doing the same thing manually requires time. So maybe that's the reason people say that human beings are smarter, because we can think in a broader perspective. But where computer excels is doing the same task again and again for a continuous period of time, and hence we need computer. So that's computer. This is another example, the very example which I have given you. It's similar to that. Again, suppose I have another equation which is x to the power 6 minus x minus 1. Now if I have such kind of equations and I ask you to find out a single solution, how will you do so? Such kind of equation, as you know, it is having a power of 6, so it will be having 6 roots, and you will not find any definite single answer to such kind of problems. Now mathematically, if you want to solve such kind of problems, what we generally refer is that suppose I have a xy coordinate. Suppose I have a xy coordinate. So this is my x-axis, this is my y-axis. Now this particular equation, x to the power 6 minus x minus 1 is equals to 0. So let me consider this x to the power 6 minus x as f of x. So for such kind of equations, we will, if we draw it, we will get some kind of arbitrary graph. This is not an actual graph, I'm just for the sake of reference I'm doing it. So what will happen is that for such kind of equations, normally what we do is that we suppose we first we apply trial and error methods. First we will give a value. Suppose we have given 1 over here, so what will I get? If I put x to be 1, then I will have 1 minus 1 minus 1, so it will be minus 1. isn't it? So it's not is equals to 0, so that's not the solution. So once I will have a value which is less than x 0, once I will have which is greater than 0, and I will keep on doing it again and again to get my final value which lies at this point. This is my actual solution. But simply putting the value of 1 2 3 minus 1 minus 2 minus 3 in place of x, we will not be able to get that. So in order to do such kind of iterations also we require computer, because as I have told you, computer can perform the same task again and again. Hence we require conm to do complex numerical problems in order to help us solve the complex numerical problem. How will he solve the numerical problem? By using certain algorithms. And what is an algorithm? An algorithm is a finite sequence of rules for performing computation. These are step-by-step procedures. Suppose I ask you to make tea. How will you make a tea? Suppose that's a problem to you. Then what we do? We will say we will first take water, we'll put it on a pan, then we will boil it, then we will add tea leaves, then we will add sugar, then we will add milk, then we will strain it, and then we will drink it. So that's the procedure of making a tea. So these are sequence of steps that has to be performed. So algorithms are basically sequence of steps that have to be performed, and my computer uses that algorithm in order to solve complex numerical problems for me. Now why the need has arisen? Because as science has advanced and technology has advanced, we are trying to solve real life practical problems, and in order to do so, the simulated mathematical model of such kind of problems is a complex exponential functions. So we require such kind of computers. We require computer to solve them. Now, what will you learn from this particular course? From this particular course, you will learn the methods of solving the problems with the help of computers. Now, this course was basically designed to take the help of C programming language to develop the codes and to solve them. But I feel that if you're comfortable with, then you can use Python also. For reference purpose, I will be in the initial period I will be discussing a little bit about the C, but then I will try to incorporate Python, because I personally feel that Python is easier to implement and it's easier to learn also. So that is what I personally will prefer. But then again, this course is basically taught in C programming language, so there is no hard and fast rule. But then again, we will learn both C and Python, but I will prefer Python. So if you are comfortable with Python, very good. If you are comfortable with C, that's also good. We will make something out of it. Now from this particular course, you will learn the algorithms. We'll learn the algorithms by which you can solve the problem. Then we will be seeing the solutions of certain practical problems. We'll take certain equations and we'll try to solve them, and we will see how the method works. Now, what is the basic requirements? The basic requirements is that you have to be committed to learn. That's number one requirement. I mean, if you are not interested in learning, then no one can teach you, to be honest. So you should have the commitment to learn. Now, how will it be helpful to you? It's something which, to be honest, I cannot answer, because it depends upon what you want to do with this particular methods. For some, this course will help them understand how to write a program seeing an algorithm. So that can be an outcome of this course. For some, they can use the methods, the formulas which we will be discussing in the following classes, and use that to solve a real life problem. So that can also be an outcome of that. So what is the outcome of this particular course will depend upon what you want to do out of it. So what will you learn from this course? I can tell you, that is, you will learn what is an algorithm, you will learn how to form an algorithm, you will learn how to apply the algorithms on a numerical problems. Now understand one thing, more or less all the natural phenomena can be somehow simulated, and a mathematical model can be developed out of it. So if you have a mathematical model for a problem, you can apply the computer vision numerical method on it and solve it. So that's it. And regarding the basic requirements, you should have a basic mathematical fundamentals that should be clear regarding integration, differentiation, calculus, metrics. I have not mentioned metrics over here, but metrics also is very important, so that those things should be clear. How will I approach? And I will try to give you a statement of the theory. I mean, suppose we have a method, suppose Rangakuta method we have. So what is that method? I mean, how can we implement that method? So I will first give you the statement of the method, then I will give you the principles, the methods, how it is basically applied. I will tell you the algorithm by which you can solve it. Then we will take a numerical methods, and I will solve one numerical method. And once I have solved a numerical method, at the end of the lecture class, I will give you 1 or 2 numericals as homework, which you will be doing, and you can submit it back to me. If you face any problem, you can always ping back to me so that we can solve them, isn't it? Now let's see the course. So this is the basic syllabus for your conm. We have we have around 6 modules. First module is computer arithmetic. Now that comprises of the introduction, which we have discussed a little bit today, and we will also be discussing in the following lecture classes. Then we have floating point representation of a number. Now what is a floating point representation of a number? See, you must understand, suppose you have a very big number. Suppose I give you a very large number. I gave you a number of this sort. I give a number, suppose 2.13678 sorry, no point 9000123, and keep on continuing up to suppose 20 places. Now how to represent such kind of big number on a computer? Your computer has a limited amount of memory. It can process a definite amount of data at a single time, based on which we have either 32-bit system or 64-bit system. So how to represent a very big number and also a very small number? Suppose I have a number like 213 into 10 to the power 30. How to represent it in computer? So for such kind of problem, we require floating points method. So we require floating point. Okay, I'm using a very low end laptop right now. Because of lockdown, my laptop is not with me, so I am using very low end laptops. I'm facing some problem. Just bear with me.